Good morning. So we will continue with cosmic physics. Last class I had told you the importance of the subject and we had just started, right? So we are left from planets, right? We have seen the definition of planet and we will proceed with other concepts. So first let us understand what is an asteroid, okay? Again, the idea is that you should write parallelly. Asteroids. I hope you have been taught about this in geography. So suppose this is Sun and this is Earth, then we have Mars and we have Jupiter. Sun should be slightly bigger, okay, obviously no issues, and suppose this is Jupiter. Asteroid belts are found between Mars and Jupiter. So asteroids are found, it means asteroid belt is found between Mars and Jupiter. So this is called asteroid. We'll see some more concepts about asteroid, but first let's understand this way. So almost 98-99% of the asteroids are found within this vicinity, that between Mars and Jupiter. But there are few asteroids which are found beyond Jupiter, okay? These are known as Trojan. So Trojan are nothing but asteroids beyond Jupiter. What is asteroid we are yet to discuss, but I am going this way because I hope geography is over, so at least you should know about the definitions. And some asteroids are between Earth and Mars. Again, very few, rare. These asteroids are known as near Earth objects. Okay, these asteroids are known as near Earth objects. So it is very clear that asteroids are mainly found in this belt, but they can be beyond Jupiter and beyond Mars as well. So asteroids are mainly rocky objects. Now some definitions. These are rocky objects. So may contain metals and minerals. We are very much interested in the study of few of the asteroids. Why is it so? So we are studying asteroids. So one is a program of NASA. Okay. So NASA is studying asteroid named Bennu. So NASA is studying asteroid named Bennu. Why NASA is interested in Bennu? Because it is of moderate size. Studying may give us the idea of the past, that how the solar system etc. was formed. Okay, so better clarity can be there. That is why we are interested to study. But Bennu is special. It is of moderate size. If any asteroid is very small, okay, if rocky object is very small, its spin will be very fast. Means its movement will be very fast. and to study those asteroids is not possible. It will be very difficult to study. So the first point is it is of moderate size. The second thing is 1 out of 600 chances of collision with Earth. That if you will give this asteroid 600 chance, then there is chance that it may collide with Earth. So the probability is 1 out of 600. Now you must, if you are following newspapers, then I am going to write something. There is another mission of Japan, Hayabusa 2. This is Japan's mission. It is studying an asteroid named Ryugu. They have named it Ryugu. Okay. So what they did? They did what? Brought clay from Ryugu on Earth. This happened this month only, but at the start. This is first ever mission to do so. So this is all about asteroids from my end. You should keep an eye on newspapers. If you are not recognizing about Ryugu, etc., then this is a concern, I would say, because you are oldest batch, I guess. Okay. Now next thing we are having is satellite. What is satellite? Satellites are the objects which revolve around a planet. Okay. Your Chanda Mama, the moon. I am not going to dictate anything on this. If you want to write in your own words. Okay. So this finishes few of the concepts. Now few more concepts are left. But before that, I want you to feel the subject. Okay. Feel the subject. I find cosmic physics to be very interesting. Just see this. This is your Jupiter, Saturn, Uranus, Neptune, Earth, not Mars. It is Venus. Mars is smaller than Earth. That is why Venus is known as sister planet, right? So it is Venus. Do not get confused ki just we are going back in the order. So it is Venus, it is Mars, and this is Mercury. Are you able to see in front of Jupiter what is the size of Earth? Okay. Now see this. There is Sun. And what is the size of Earth in front of Sun? Are you able to find that? Are you able to find? Okay, if you are able to find yourself. Sun is just one of the smallest stars of our solar system. Okay, even in our solar system, Sun is not the biggest star. Sorry, in our galaxy, and there are millions and zillions of galaxies in the entire universe. Find yourself. If time permits, we will doing dark matter today only. Then I will again ask you to find yourself. Okay. But in this visible world, are you able to find that out of zillions of galaxies, okay, we are finding just one star among zillions of stars, and that small star is way bigger than Earth. And where are you? Nowhere. फिर भी इतना घमंड है आपको. Okay. Now let's come to comet. Comet looks like this. Okay. Comet is always, sometimes defined as Puchhal Tara. Okay, in Hindi. Comet is called Dhoomketu Puchhal Tara. In Hindi it is called. So here we are having comet. So this is the nucleus of the comet, and this is the tail of the comet. Okay, this is the tail of the comet. Nucleus is containing of dust plus ice, means this is something icy, okay, plus gas. Which sort of gas is found? Ammonia, methane, etc. In other words, these gases are flammable. They will catch fire. Yes or no? So the same happens. Suppose this is your solar system. This is your sun. My question to you is that comets revolve around sun or not? Yes, they do. So comets revolve around sun. So suppose they are revolving around sun this way. So this is your comet. Now let me tell you that when comets come near the vicinity of sun, okay, listen to me very carefully. When comets come near the vicinity of sun, because of the heat of the sun, they find fire in their tail, because these gases start burning. Because of that, a tail develops. Okay, so the tail develops because of the heat of the sun. When the comet again moves away from the sun, everything settles down. Okay, so comet is these sort of object, means they revolve around sun. This point you need to remember. And why there is a tail? Because the gases catch fire, revolve around sun. One more important point I am going to make. Do not ask about this point as of now. When you will come to know the concept, you will know this, right? So at present, just write it, copy it. Kuiper belt and Oort clouds are the home of the planet. Home of the comet, sorry, planet I am saying. Okay, now focus on PPT. Some more concepts are there. Again, these concepts are, older concepts. I should not devote much time on this, but I am bound to. Just see this PPT. So what is a meteoroid? What is a meteoroid? Meteoroids are chunk of asteroid or a comet. So meteoroids are nothing but chunk of asteroid or comet. Okay. Suppose a part of asteroid comes out or part of comet comes out. So this particular heavenly object will be known as meteoroid. Okay. Suppose this meteoroid is approaching towards Earth and this is the atmosphere of Earth. 99.9% or 99% of the meteoroids vanish in the outer atmosphere of Earth because they catch fire due to friction from air. So there is friction, okay, that friction is known as drag force in physics, but understand this, that they catch fire and they are gone. But few of them are very willful or very obstinate or stubborn that they enter in our inner atmosphere also. Because of that, air density increases and hence the drag force increases or the friction increases and more fire is observed, and this is known as meteor or shooting star, Toota Tara, from where you ask God, please UPSC nikalwa dena is bar, right? So you ask wishes from these, but these are nothing but these heavenly objects, okay, the chunk of comets or asteroids. Almost all the meteoroids end over here, but few of them are again very willful that they reach the surface of Earth, known by the name meteoroid. So very I'm writing this, okay, copy this parallelly. I won't give you much time here because these things I believe. Meteoroid, right? This is meteorites. Okay. So these are nothing but chunk or part of asteroids or comets. They vanish in outer atmosphere of Earth. Meteor. These are meteoroids entering inner atmosphere. Okay. Also called shooting stars. Okay. May have different colors, means they can give you different color of shooting, right, due to different minerals present in them. And meteoroids, what are these? I don't know. These are meteoroids reaching surface of Earth. This meteoroid can be big or small because they are reaching surface. If they are big, they wipe out civilization. Example, dinosaurs. Or they create landscapes. Example, Lunar Lake in Maharashtra. And if they are small, we study it in keeping them in labs, right? I hope this should be clear. Okay. Now focus on the PPT. Feel the subject, PPT. Suppose this is your sun and suppose this is a planet. So planet will revolve around sun or not? Yes, planet will revolve around sun. Suppose this is asteroid. Asteroid will revolve around sun? Yes, asteroids will also revolve around sun. Comet. Comet will revolve around sun? Yes, comet will also revolve around sun. Apart from these three, nothing in our solar system revolves around sun. Okay? Only these three revolve around sun in our solar system. Planet, asteroid and comet. Okay? Now consider the entire page as the galaxy. Okay? Our solar system is in Milky Way galaxy. So let us consider the entire page as galaxy. I have tried to put a simplified presentation. Okay? So consider that way. So this is the center of the galaxy. Okay? Now just understand very clearly that sun is not at the center of the galaxy. You have to keep this thing in your head. Okay? I will tell you why it is so, but at this point of time just remember that sun is not at the center of the galaxy. And suppose this is the diameter of the galaxy. Okay, I am just considering this this much. This is the diameter of the galaxy. Can you just imagine the dimension of the diameter? It is 1 lakh light year. 1 lakh light year means if light wants to travel from one end of the galaxy to other end of the galaxy, it will take 1 lakh year. Wow. It means by that time how many generations of humans will be no more. Are you getting this? So just think that how big the galaxy is, and this is only one galaxy. There are millions, skillions, zillions of galaxies. I don't know what is the limit. I know there is a proverb, sky is the limit. I don't think so. Okay. So 1 lakh light year. You need not remember the data, just understand the gravity of the subject. And sun is almost 33,000 light years away from the center of the galaxy. Though this is not 33,000, you can understand here, but I was bound to make such because complexity of the diagram will be more if I will understand this by mapping the dimensions, okay, measuring it accordingly. Just understand that is 33,000 light years. 33,000, it means even the rays of the sun take 33,000 years to reach to the center of the galaxy. My God, how big it is, how big, beyond our imagination, right? Now I am going to tell you about life cycle of star. Okay, so life cycle of star, it starts with nebula. Anand is asking how can a meteorite wipe out the whole civilization? Not whole civilization, a part of civilization. Suppose it falls on part of Africa, so that civilization will be gone. India's civilization is definitely different from the civilization of Pakistan. I am not asking about human civilization, I am asking about the racial civilization. For example, dinosaur was one species that was wiped out because that part of earth was targeted by the meteorite. Okay, Anand. So suppose this is nebula. बंद कर दो पीपीटी बना दो, पीपीटी बंद कर दो. Okay, now we are going to deal with life cycle of star. I will make on board. You are supposed to write it parallelly. Then I will make you understand. Okay, I will be making you understand parallelly only, but writing is important. Life cycle of star is very much important to be understood. And from here we are starting our cosmic physics. Okay, till now we were just revising the geography. Now my part starts, life cycle of star. This phase of star is known as nebula. Okay, nebula is nothing but womb of a star. Okay, here dust and gas accumulate okay, so this is a collection of dust as well as gas, and if gas I am saying it, gas is hydrogen only. Okay, so this is collection of dust as well as gas. Understanding this? This process takes around millions or billions of years. Every phase of star lasts around billions of years. For example, your youth, it is around 15-20 years. Your childhood, okay, 8 to 10 years. Your teenage, 7-8 years. So every phase is defined and it is very limited. But for a star, it is highly unlimited. Every phase takes around billions of years. Okay, for example, the gestation period for a woman is 9 months. For the gestation period of a star is billions of years. So this accumulation of dust and gas happens for billions of years. And the dimension of this is 1 to 9 light years. So dimension of the womb is in light year. Light year is the distance traveled by light in 1 year, and the speed of light is very less. Which roughly known as 3 lakh kilometer per second, right? So in 1 second it travels 3 lakh kilometer. Just imagine in one year how much distance it will travel. So 1 to 9 light year is the dimension of this nebula. It means light will take 9 years almost to travel from this into that end. So this is a nebula phase. What happens in nebula? Just try to understand. This is very important concept I am going to tell you. In nebula, the dust particles try to come closer. So this is dust particle. They try to come closer. Dust particles, they try to come closer. Why? Because of force of gravitation. So gravitation is the force which is trying to kill the star actually. Why? Because if all the dust particles accumulate, don't you think it will become a lump of mud? Instead of having its own light, it will be just a lump of mud. That will be known as a dead star. That will be miscarriage of star. Okay? Red dwarf. It is known by the name red dwarf. We are not interested. So the point is that the gravitation tries to kill the star because the dust particles have mass, right? And anything having mass will attract each other. This is the law of gravitation. So they will try to come closer by the force of gravitation, and this can kill the star in the womb itself. Means star will not be born. But something happens here. What happens? The hydrogen gives you helium plus stellar energy plus neutrino. You remember this? The fusion reaction, nuclear fusion. Now just see, in this process helium is formed and stellar energy is formed. Stellar means related to star. This stellar energy saves this star. This is Godfather over here. So this counters the gravitation of dust particles. So stellar energy counters gravitation. Because of that, there is birth of the star. And the star is known by the name protostar. Okay, so understanding this or not? So this stellar energy is actually saving the star. Let me tell you, whatever the thing you are having around you, every energy is owing its existence to this stellar energy. You will eventually understand. Protostar is your infant star. Here, fusion process had just started, or it is moderate fusion mechanism is there in protostar. This phase of star, that is infancy, this will also go for billions of years. Okay. So in protostar, what happens? Fusion reaction intensifies. A time will come when fusion reaction will intensify. Because of that, the star will convert itself into main sequence star. This is the youth phase of the star. Okay, this is main sequence star. One point you can know, Sun is a main sequence star. At present, Sun is in youth phase. So I hope that this part is clear. Now here something happens, and something happens which changes the entire life of the star. You know, some life changing events happen to your life. For example, when you choose the path of engineering, that was a life changing event, good for nothing. Then you choose the path of being IS aspirant, that is again life changing event. Either you will be an IS, that will be your life changing, else you will regret also. I am not discouraging, just a part of joke. And third life changing event will be your marriage, right? That is the biggest life changing event. So same thing happens here with the star. What happens here? After billions of years, for example, fusion reaction is at its peak, right? So after billions of years, what will happen? Fuel of the star will vanish. Though fuel was so much, okay, dust, the gas was there for 1 to 9 light year, but it was limited. Anything cannot be unlimited here. So there was limited. So what happens? Fuel starts to decline. Okay. So when more than 90% of the fuel is over, 90% of fuel means hydrogen is consumed. When more than 90% of the hydrogen is consumed, star becomes panic. Why star becomes panic? Because stars remembers the day when gravitation had tried to kill the star, and it was only the hydrogen which after fusion provided stellar energy to save the star. So star becomes panic that gravitation is going to kill me. And this is obvious because this has happened to a star once, right? You just understand this example that suppose you are driving, okay, and your car or bike is in reserve mode. After some time you find that petrol in reserve mode is also very less. You won't be able to reach the destination. So what happens? You become panic that I need to reach nearest fuel station. Else what will happen? I will have to drag the vehicle by my own. So what do? You just start driving without looking at anything. okay, that whether you are going to hit something or you are breaking signal, because you have only one shot, that the engine is in its mood and you need to reach the fuel station. Okay, so that happens here. So main sequence star, 90% of the hydrogen is over. So as your speed increases, so here also consumption of hydrogen intensifies. Okay, because of that size of the star becomes big, and this is known by the name red giant. Okay, suppose this much energy was required. Okay, this much energy was required for countering gravitation, but it had consumed this much energy. So don't you think the size will increase? Yes, size increases. So here hydrogen is almost over. Hydrogen is almost over. So you reached the fuel station at least, where the fuel is over. You said extra premium dal dena. He said extra premium is not available, sir. Then you said that okay, 70 octane number का fuel डाल देना. The guy at the fuel station may say, सुबह सुबह पी के आए क्या सर आप, क्या बकवास कर रहे हैं? We have only extra premium and normal petrol. ये octane कुछ नहीं. Okay, so do not use your chemistry there. Just ask for extra premium or anything else. So their extra premium was not there. Will you think at that time that knocking of engine will happen? No, you will just get the petrol because you do not want to sit at the fuel station for next 2 days waiting for extra premium. No, you won't do that. Practically no one will. So the same happens here. Hydrogen is almost over and now the gravitation is ticking. Ab tera kya hoga Kalia? Right? Gravitation is ticking over here. Gravitation is trying to kill the star. But the helium over here, the helium proposes a star. सरदार मैंने आपका नमक खाया, राइट? मैं आपका फ्यूल बनूंगा. सो बोले ओके. सो हियर helium becomes the fuel. So can you understand the fueling mechanism of the entire star is changed. So different reactions will happen here. Hydrogen and some hydrogen will be left, will give you lithium. Helium and helium will give you beryllium. Helium and beryllium will give you carbon. Helium plus carbon, oxygen. Okay, so here up to oxygen elements are formed. Okay, so after some time the star appears like this. I mean red giant. Carbon, oxygen at the center, beryllium, lithium and helium. Why is it so? The heaviest element will try to sit at the center. Just earth crust. What happens at earth crust? The heaviest element, that is iron, is at the core. The heaviest thing will sit on the core. So this is obvious, there is no issue in this. Okay. Now here after some time when helium is also over, okay, helium is also over. Now lithium, beryllium, carbon, oxygen are stable. They cannot give fusion reaction because the nucleus is so big. So fusion reaction is not possible there. Okay. So there is no replacement of helium. This phase is also for billions of years. So after billions of years nothing happens and star is bound to die. So what happens? Star collapses because of gravity at carbon oxygen core. So this core is there, so star collapses. Because of that, this collision, we find two things. One is your planetary nebula. and other thing we find is white dwarf. Okay. This red giant is mature or old star. This white dwarf is fossil or dead star. And this Planetary Nebula is nothing but understand like graveyard. This is graveyard. Just understand like this. So white dwarf is a very dense mass. We'll talk about this, don't worry, in detail. Just as of now, just understand this. So this is white dwarf, dead star. So this is the life cycle. This Planetary Nebula or the graveyard, okay, what this will do? This acts as nebula for a new star. Means where a star is dead, a new star will be formed after billions of years. So a star has to born, a star has to die. First copy that, okay, then we will discuss bit more. This part I am trying to make you understand. Okay, this part. When a star collapses at carbon oxygen core, what happens? Suppose it is collapsing. So don't you think gas etc. thing will come out and a very dense mass will be remaining? Understand like this. Suppose this is a gassy object. Okay, gas is fulfilled and some mass is also there. It is collapsing. So what will happen? Gas will come out and some dense mass will be left. So this dense mass is white dwarf and the gas which is coming out is Planetary Nebula. Okay, so Planetary Nebula is again lump of gas. Okay, so that is why this is acting as nebula for a new star, but it will also take time for billions of years. So just understand once more. Suppose this is a gaseous object, it is collapsing, so dense mass will be left and gas will come out. So that is what is written. Copy it ASAP. Okay, this was the life cycle of a small star. This was life cycle of a small star. Now give heading life cycle of a big star. Diagram is on the board. I am going to change for myself. Okay, you are supposed to make it again. Okay, I will give you time, don't worry. So now for a big star. This should be greater than or equal to 10 light years. So that is considered to be a big star. Okay. So for a big star, just size of nebula will change. It will be more than 10 light years. Again the same thing will happen. A gravitation will try to kill the star, and because of that hydrogen has to provide the stellar energy to counter the effect of gravitation. Again burst of the star will happen, again fusion will intensify, main sequence star will be there. When 19% of the hydrogen is consumed, then consumption will be intensified because star is in panic situation that gravitation is going to kill. But since 10% of the hydrogen over here will be more, so instead of red giant it will become little bit more bigger, so it will be known as red supergiant. So after that, the second change is here. The first change was in the size of nebula. The second change is red giant. Instead of red giant, we'll get red supergiant. And here we will get elements up to iron. Fe means iron. So here you were getting up to oxygen. Here you will get up to iron. Accordingly, we will change this. Iron is the heaviest, so it will sit at the center. Then we will have carbon oxygen. Then we will have silicon. Sorry. Silicon is heavier here, so it will be here. Carbon oxygen, beryllium. Now here the big change will be seen. So the first change was there, second change is red supergiant, third change is here because different elements are getting formed. So star here will collapse at iron core when helium is also over. The same thing. Helium is also over, star will collapse at iron core because the core will be of iron. That will lead to supernova explosion. That will lead to supernova explosion. After supernova, if it is a big star or if it is a medium star, if it is a big star, black hole will be formed, and if it is a medium star, neutron star will be formed. So both are again fossil star or dead star. So copy the entire thing. The changes are from the red supergiant. I am giving you 5 minutes. पहले उधर दिखा फिर पूरा दिखा. PPT on. Now focus on the PPT. I hope you have written this. So when to know a star is big or a star is small or it is a medium star? So this was deduced by an Indian scientist, Subramaniam Chandrasekhar. So he gave the formula and it is known as Chandrasekhar limit. Okay. So the formula given by him is known as Chandrasekhar limit. So he found that which star is going to die which death. Okay. Let me tell you that he is the nephew of C.V. Raman. The same C.V. Raman we had done in the first class, Raman effect. So he was also Nobel Prize awardee, and Mr. Subramaniam Chandrasekhar, he was also given Nobel Prize. So he is not like that Chacha Vidhayak hai hamare. Okay, he himself became the Vidhayak. That sort of thing. Means he himself got the Nobel Prize instead of boasting the same. So to date I have taught you 3 Nobel Prizes. Photoelectric effect, Raman effect, Chandrasekhar limit I am going to teach, and after the tomorrow, not today, tomorrow I will teach you Higgs boson, the 4th Nobel Prize. So 4 Nobel Prizes have been covered. And if you want to link today's black hole concept with concept of galaxy, then that will be the 5th Nobel Prize. No issues. Chandrasekhar limit, let's discuss what is it. So he said, if mass of the core is less than or equal to 1.44 mass of the sun. The second equation he gave, that if mass of core, that iron oxygen, carbon oxygen core or iron core, whatever you have seen, 3 mass of sun. Mass of sun has been kept as reference because it is and greater than 1.44 mass of sun. And the third is mass of core is greater than 3 mass of sun. Here the star will die as white dwarf. Here the star will die as a neutron star. And here the star will die as a black hole. We'll see the concepts one by one. First copy the equations, then we will understand what is white dwarf, neutron star, black hole, anything. Okay. Before covering white dwarf, neutron star or black hole, let us understand supernova explosion first. Okay, what is supernova explosion? We had seen that there was an explosion for a big or medium star when the star was collapsing at iron core. So this is a very big event. Let me tell you that during a supernova explosion, a lot of light is emitted, and the amount of light if measured will be equal to billions of stars, or you may say billions of sun giving light for billions of years. Wow. Can you imagine? Can you imagine the gravity? Means billions of sun giving light for billions of years. That humongous light will be equal to the amount of light emitted during a supernova explosion. So this is a very big event in the cosmic world. So write about supernova explosion. Then I will give you the point that is more important for UPSC. First write, what is supernova explosion? Right. It is a big event in cosmic realm. It is a big event in cosmic realm that happens when a star collapses at iron core. When a star collapses at iron core. Next point to write. The amount of light emitted in the process in the phenomenon above, rather you write, the amount of light emitted in the phenomenon is equivalent to the amount of light emitted by sun for billions of years. Big event, then billions of suns can also be there, no issues. Emitted by sun for billions of years. For billions of years. Now very important point. Just see red giant. In red giant phase, we were getting elements up to oxygen. In red supergiant phase, we were getting elements up to iron. What about heavier elements like uranium, gold, silver? Those heavy elements are formed during supernova explosion. So right here, during the explosion, heavier elements than iron like uranium, gold, silver, etc. are formed. Uranium, gold, silver, etc. are formed. One more very beautiful observation, right? Just see, oxygen, nitrogen, everything is formed in red giant and red supergiant phase. Are you able to appreciate this? We are getting carbon, oxygen, nitrogen. Now just understand, what is life? You are composed of carbon. Your body is having carbon, potassium, calcium. The life of DNA. DNA will have carbon, phosphorus, nitrogen in it, oxygen in it, right? Are you able to appreciate this? That any organism is made of those elements, and those elements are formed during red giant or red supergiant phase. So you all are part and parcel of a star. You all are star dust. So if your mother says कि मेरा बेटा चांद का टुकड़ा लगता है या बेटी चांद का टुकड़ा लगती है, तो just correct her by saying तारे का टुकड़ा, right? Because you all are chunk of star. Because stars have given the life to the entire, cosmos. You may say it like this. Okay. So whatever the elements are there found in your body belong to a star. and whatever the elements you utilize for anything else. For example, that gold, the gold ring or gold chain you are wearing right now, you have not bought it from Tanishq. It has been the legacy of the star during supernova explosion. Okay, so whatever they have done, they have got it from the supernova explosion. So just think that this part was someday, this part of chain someday was in the cosmic realm, maybe many light years away from you, and from where you have got it, you have no idea. Understanding this? So how beautiful this is, right? Okay, no issues. Now let's come to white dwarf. I will tell you about white dwarf, okay? Then I will make you write also, don't worry. So white dwarf is formed when? When star collapses at carbon oxygen core. This was the idea. So the explosion is very intense over here. So here neutron and protons are there and electrons are there, right? This is what is the thing. In white dwarf, when the collapse at carbon oxygen core happens, every atom over there feels the pressure. Because of that, every electron jumps into the first orbit. Are you getting this? Every electron jumps into the first orbit. So your every atom will look like this. There will be neutron, proton, and here around electron, electron, electron. So every electron will be in the first orbit. Those who are having the knowledge of Pauli's exclusion principle may question me, but please do not, because I am talking about quantum physics. In quantum physics, Pauli's exclusion principle is not valid. So this state where every electron is reaching the first orbit is known as degenerate gas. So in quantum mechanics it is known as degenerate gas. Understanding this? So are you able to see that all the electrons have reached the first orbit? So because of that there is shrinking of the star. There is shrinking of the star. And if star is shrinking, I can say volume has declined, right? And if volume has declined, you can clearly say density of the material will be very high. Because of that, white dwarf is very high dense mass because the volume declines. I repeat, when there is intense collapse, so what happens? Every atom faces that collapse. Because of that, every electron reach to the first orbit, and the state is known as in quantum realm is known as degenerate gas. Since here every atom is shrinking, that is leading to the decline of volume, which ensures density is very high. Okay. If anyhow you get a chance to come closer to a white dwarf, and suppose you have one spoon, so if you will try to take 1 spoon of white dwarf, it will weigh around 100 to 1000 tons. Means 1 tablespoon weighs around 10 to 1000 tons. Can you imagine how dense the mass is? It is very dense. Okay, 1 spoon is 10,000 tons or 1000 tons, very, very dense. So please write white dwarf. This is formed, white dwarf. This is formed when a small star, collapses at carbon oxygen core. collapses at carbon oxygen core. Next point you write, this collapse is so intense, that every electron in each atom reaches the first orbit. Due to which volume decreases and hence density increases. This state in quantum mechanics is called degenerate gas. Right. Next point, white dwarfs are glowing objects in the universe without any fusion mechanism. Right. Let me clarify over here. White dwarfs are very dense objects and they will be glowing all the time, right? But fusion is not there. Why is it so? They are like the kids of Ambanis, that their father and forefathers have done a lot of hard work. Because of that, they have a lot of money, right? Even their earning is not there. Okay, they do not earn anything, but yes, their forefathers have given them a lot of money. सात पुश्ते बैठ के खाएंगे. You must have heard. So if you are not having money with you, it means your forefathers and fathers have not done up to the mark. This is not your fault. Okay, just kidding. So you must be understanding that they will be glowing, but they have no fusion mechanism because no hydrogen or helium is there. I hope you remember. Now let's come to neutron star. Okay, so neutron star will be formed when star will collapse at iron core, right? And it will again a very intense process. So here the intensity of the collapse is so much that every electron enters the nucleus. So instead of reaching the first orbit, it reaches the nucleus. So here what happens? Every electron reaches nucleus. So electron will find two things in the nucleus. First is your neutron, other thing will be proton. Electron is since having -1 charge, proton is having +1 charge and neutron is having 0 charge. So electron feeds upon the protons. So electron and proton react to give you neutron. So are you able to see? This neutron was there and only neutrons are there. So in the entire star, only neutrons are found. That is why it is known as neutron star. There is no proton, there is no electron, only neutron. I repeat, here the intense is so, the collapse is so intense that every electron enters the nucleus. In the nucleus, electrons have affinity towards protons, so electrons and protons react to form neutrons. So in the entire star, only neutrons are left. Because of that, it is known as neutron star. Okay? And this star is also known as pulsar, like Bajaj pulsar. Why? Because it accelerates any particle which enters in its magnetosphere. Okay, for example, it will have its range. See this. Suppose this is a neutron star. So this star will have its magnetosphere, like Earth's gravitational field. It's have a magnetic field. So if anything enters here, acceleration of that thing happen. If it was at 10 km per second, it will reach a speed of 1000 km per second. Right? So acceleration of that thing will happen. So that is why it is known as pulsar. Like why Bajaj named its bike as pulsar. Acceleration was fast in that bike. So please write neutron star. These are formed due to death of a medium star. These are formed due to death of a medium star. Medium star. Next point you write. When a star collapses at iron core, when star collapses at iron core, all electrons in every atom, all electrons in every atom enter the nucleus. Enter the nucleus, where they feed upon protons, to give neutrons. Hence only neutrons are left. Hence only neutrons are left in the star. Hence they are called neutron stars. Or so they are called neutron stars, whatever you want to write. So they are called neutron stars. These are also called pulsar or pulsar. Because they accelerate any particle entering in their magnetic field. entering in their magnetic field. Entering in their magnetic field. Okay. Black hole we will do after some time. Before that, there are some questions on the PPT, very easy questions because we have done very complex topic. But yes, that should not be that complex. Revise it, you will come to know. If you want the short version of that, I will give you. I do not have any problem. If you want the short version of that, life cycle of star, I will give you the short version. If in exams, suppose mains exam, accidentally they ask about this. So suppose what you can do? Nebula. After nebula you will get protostar. After this you will get main sequence star. Okay. And if it is a small star, you will get red giant. Okay. Apart from this, other stars, you will get red supergiant. And here, collapse at carbon oxygen core, that gives you planetary nebula and white dwarf, which is your fossil star. Red supergiant collapse at iron core. This will lead to supernova explosion. And here you can differentiate. If it is a medium star, it will die as neutron star. And if it is a big star, it will die as black hole, that we are yet to see what is it. So this is short version. If you are making this is equally competent model to fetch you marks. Because 200 words or 250 word is the limit. So writing that much information will not be necessary in the examination. But yes, if I would have not given you that much concept, then understanding the entire concept will be difficult. Try this question. I am giving you very easy questions. There are around 5 questions. All questions are, these questions have never been asked in UPSC. Okay, I have just given as a revision exercise so that you can feel happy that you have learned these things. These are very easy questions. Okay, the following 5 questions are very easy questions. Okay, I have got Chhawa and Anand both have given option C. Yes, option C is the right answer. It should be fusion. Okay, sometimes we go for fission. Fission reaction is not in sun, it is fusion. Yes, Rohit Kumar has also gone the right response. And Utkarsh has also given the right response. Try this question. Palash. Yes, your answer is also right. Now try this one. Sandeep Kumar Yadav, yes, you are also right. I have not taught you, okay? Actually, I was supposed to teach you, but I forgot. That is why these questions are there. That if accidentally I forget to tell you anything, these questions should remind me. Like this part I had missed. Okay, Rohit Kumar has come with the answer. Utkarsh has come with the answer option C. Vivek Gupta has also come with the option answer C. Yes, C is the right answer. See, in cosmic world, if anything is appear to be red, if anything is appear to be blue and if anything is appear to be yellow, what is the meaning? Rakhi has also given right answer, option C. If it is red, it means it is hot. No, it is cool. If it is blue, it is hot. And if it is yellow, it is moderate. So the color indicates the temperature. Okay? Red means cooler, blue means hotter, and yellow will be moderate. Second thing, if something is appearing to be red also, it means it is away from you. This point you can also remember. And if it is blue, it is near to you. These 2 points you remember, why it is away and why it is near, I will be telling you tomorrow. Tomorrow we are also having class. Anand, you are also right. Sandeep Kumar Yadav, you are also right. Option C is the right answer. What should be the answer of this? Yes, option D, Vivek, Chhava, Rohit, Anand, Utkarsh, everyone has given the right answer. And Ajit, yes, you are also right. Utkarsh is asking, without fusion, how do white dwarfs produce light? The same I had answered. They are grandson of Ambani's. Their forefathers have left a lot of money. So without earning also they have a lot of money. Okay, so star is in proto-star phase or main sequence star phase or red giant phase for billions of years. So a lot of light is accumulated in the star itself. That is why it is luminous. Anand, Palash, Ajit, Vivek, everybody has gone for the right response, nebula. Because other three are part of solar system. They revolve around sun. Okay, Rakhi, you are also right. In last option there was a dog star. Dog star doesn't mean that stars have a pet. Okay, dog stars are called brightest stars in the sky. Okay, brightest star, because dogs have the tendency to attract your attention, right? They will make their face, that is known as puppy face, right? Or they will bark to draw your attention. In the same fashion, dog stars are very bright, so they draw your attention. That is why they are known as dog star. Ajit Kumar Singh, Utkarsh, Chhava, okay, Sandeep, Rohit, Vivek, everyone is right. It is neutron star. Okay, so now the next concept is black hole. We will do it after the break, probably 5 minutes break. Okay, thank you. Okay, let us resume with black hole. This was the topic we have left. So what is a black hole? Black hole is the object in the cosmic world, okay, through which even light cannot come out. Through which even light cannot come out. These are extremely dense mass. Okay. For example, we had talked about white dwarf. I told you that one spoon will weigh around 10 tons to 1000 tons, right? For a neutron star, one tablespoon will weigh around 10 million tons. Okay. Have you ever watched movie Thor, right? Thor. So the hammer of Thor is made up of neutron star as per the movie. So you can just imagine that one spoon is weighing around 10 lakh tons. So how dense the mass is. And black hole is even way beyond. You cannot imagine that how dense it would be. Right. So just say this, that suppose this is a black hole and this is called event horizon of black hole. Event horizon means the place up to which the gravitational pull or the magnetic field of the black hole is acting, or the attraction of black hole is acting. You can be anywhere in the cosmic world, okay, anywhere you can play here, anywhere, there is no issue. But accidentally, if you enter the event horizon of black hole, you come to know that you have committed a mistake, okay, because after multiple attempts also, you won't be able to come out, you will enter in the black hole. This is so because the escape velocity, okay, to overcome the gravitational pull is even more than that of speed of light. And this is the first principle of theory of relativity that we are going to see tomorrow, that speed of light is maximum. No object in the universe can match the speed of light. So even if light is not coming out, take it from me, no object will be able to come out of the black hole. So black hole is highly supermassive and super dense mass. Okay. Rohit Kumar is asking question. We are able to take pictures of black hole located millions of kilometers from our galaxy, but not the one present in our own galaxy. Why so? Rohit Kumar, kindly answer me one question, that before teaching black hole you are asking this question, whether this is to test my intelligence or this is your curiosity. This is my first question. The second question is, first answer me that if light is unable to take picture of a black hole, okay, if light is not able to come out of black hole, how we are able to take the picture of black hole? This is my second question. So please answer these two questions, then I will answer your question. Before the topic, I do not want that you should ask any question. And this habit is really not appreciated. Now just see here. That suppose this part is known as singularity, and this is the event horizon of the black hole. So if anything will enter here, it will enter into singularity. No object here is allowed to come out. Are you able to see? This is unidirectional. Okay. Why is it so? Let me answer you first. Okay. First thing is, this is black hole. The entire mass of black hole is situated at this single point, which is one-dimensional point. Listen to me very carefully. The entire mass of the black hole is located at a single point, which is a one-dimensional point known as singularity. Okay. Since black holes are supermassive objects and the entire mass is concentrated at one point, so at this point gravitation is infinite, because such a big mass, an entire mass is concentrated at a single point. So don't you think the gravity or the density of that place will be maximum? So if density is maximum, gravity will be following the same. So gravitation will be infinite. So any object which will enter the black hole will enter into singularity. That will not be able to come out. Okay. So any object that enters here enters singularity. Suppose you are a 3D object, right? You are a three-dimensional object. So entering singularity means a 3D object, if falls in a black hole, its dimensions dimensions are broken. Okay, its dimensions are broken and it enters into one dimension. So this three-dimensional object will become one-dimensional object, because from everywhere gravitation will be working on it. This process is known as spaghettification. That any object falling in the black hole, okay, enters into singularity. So first you write about black hole, then we will discuss a bit more, right? A black hole is a massive object in the universe, from which or from where even light cannot come out. From where even light cannot come out. This is because of the extreme pull of the black hole. This is because of the extreme gravitational pull of the black hole. Extreme gravitational pull of the black hole. The gravitation is so much because the entire mass of black hole is concentrated at one-dimensional point. Known as singularity. Any object falling in a black hole loses its dimension and attain one dimension called singularity. This process is called spaghettification. This process is called spaghettification. Next point to write. These are dead remains of a big star These are dead remains of a big star, and they warp or curve, they warp WARP or curve space-time infinitely. They warp or curve space-time infinitely. This point we will understand tomorrow. The last point, curving of space-time, we will understand tomorrow. Else everything I have told you. Now let's focus on galaxy first. Okay. Then there are a few questions like Rohit has asked. He is very curious to know. So I will answer after this. First, see galaxy. See the PPT. Suppose this is a black hole and suppose this is a black hole. If event horizon of these two black holes come closer to each other, then they will collide to give you a bigger black hole. Okay? But if these two if these two black holes are way separated, they form galaxies. What I mean is, at the center of any galaxy there is a black hole. So black hole is the massive object which bounds the entire galaxy. Like when I was talking about today the Milky Way galaxy, okay, I had asked you to assume that page as the Milky Way galaxy, right? So we had seen that sun was not at the center. At the center there is a massive object known as black hole. This year's Nobel Prize is awarded for this finding, though we were studying for last 2 years. Okay, I am not saying this was my discovery, this was their discovery only, but we were studying. So what I meant to say is that at the center of any galaxy there will be black hole. It doesn't mean that in the entire galaxy there is only one black hole. There can be millions of black holes in the galaxy, but one black hole will be central to bind the entire galaxy. So that black hole will be at the center. So in our Milky Way galaxy also there is a black hole at the center. Okay. So this is the first thing. So first write this galaxy. Everybody knows it is a collection of dust, gas, billions of stars and their solar system. But it is bound by a black hole. That is the addition that I am going to make. Right. It is a collection of dust, gas, billions of stars, and their solar system, and their solar systems, comma, all bound together by gravity via a black hole. Via a black hole. Now some questions. So I told you that if two black holes are coming together, they will form a big black hole. And if two black holes are way separated, they may form two different galaxies also, right? We have talked on this. See, the making of galaxy is a very complex process. For example, Rohit, if I was harsh on you, I am very sorry for that, but you asked two questions and two questions were asked just before teaching the topic. First, you asked about the black hole. I had not touched the black hole. You have asked about quasars. I had not touched galaxy also. Why you are asking such terms? Okay, so if I was harsh on you, I am very sorry, but my request is, if the topic is over, after that you ask, it is easier for me also and for the entire class. Now see, you have asked about quasars. So these are very glowing places in universe. Okay, these are very glowing places in universe. Let me tell you, quasars are bound by probably a neutron star or a black hole at the center. Okay, so this is at the center, a black hole will be there. So in other words, you may say quasar to be a primitive galaxy or galaxy in making. That is it. So suppose if I was telling you that black hole at the center and that is a quasar, I would not be able to relate it with galaxy, because the definition of galaxy is not known to many people in true sense. They know only about the collection of dust, gas, star and their solar system, but not the concept of black hole. So this is what is quasar. Your second question was, Rohit, we are able to take pictures of black hole located millions of kilometers, okay, from our galaxy, but not one present in our own galaxy. Why so? Actually, we have deliberately chosen that black hole that was far away from us, okay, and the size of this was even 300 times the size of our sun. So it was easier for us to take the picture of that black hole. We selected that black hole because of its size, massive size. Okay, our black hole is not that big. So we were wanting that we should take a bigger black hole because we were bound by data. Why data here? The second question I had asked you, because of that. For example, if this is a black hole, right, and this is suppose event horizon of black hole. So if light is entering here, light will not be able to come out. You are able to see this particular pen because light is getting reflected from the pen. How can you see or how can you take a picture of black hole if light is not getting reflected from the black hole? Right? So we wanted a lot of data. So what we have observed, see, near event horizon there are many gases, and here the temperature is too high. So when these gases touch the event horizon, they give you ultraviolet rays. So these ultraviolet rays were captured by Event Horizon Telescope. See, the questions you are asking has no relevance with the syllabus of ours, right? But because of your curiosity I am asking. But my only request is ask this after the topic. So just understand once again that this black hole picture cannot be taken by the visible light because visible light will not be able to come out. So whatever the gases are around the black hole, the event horizon, they after getting evaporated or getting heated give you ultraviolet rays. These ultraviolet rays were captured by the Event Horizon Telescope, and because of that data we have framed a manipulative picture of black hole. That picture may not be the accurate but near accurate. Understanding this? So we have chosen that black hole because of data factor, because we need a lot of data to frame that thing because reflection of light is not possible. Okay, so this was the answer of your question. Next is Mr. Utkarsh. In white dwarf, light cannot be accumulated, especially by a star. Request you to throw some more light on it. Why you are so much worried of white dwarf? See, white dwarf is all about the quantum mechanics. Okay, first thing. Second thing is, I told you very in easy terms that white dwarf has more light because their forefathers have done a lot of work. But I guess you are not happy with my explanation. White dwarf is formed when the star collapses at carbon-oxygen core. Because of that, extra gas is fumed in the atmosphere or is flushed out in the atmosphere, which is known as planetary nebula. So when this thing is done, this becomes a super dense mass or a fossil star. So this is dead star. The temperature here in the interior is very much, okay? The temperature here is too much. Because of this temperature difference and the quantum state of degenerate gas, some light is emitted. So that emission is because of that temperature. That temperature is around 10 to the power 7 Kelvin, okay? A huge temperature is observed over there. So that can be a reason of that, okay? The accumulation is not the factor, but try to understand in layman terms. We are not here to research for the white dwarf or black holes, how the picture was taken, okay? No issues. Let's move to next topic, Kuiper belt. Okay, between Earth and Jupiter we had a belt. This belt was known as asteroid belt. We have done this asteroid belt, the first topic of the day. Beyond Neptune we have again a belt. Okay, I will use another color. Okay, I use another color for Pluto only, okay. So Pluto is blue. Pluto is not a so this belt is known as Kuiper belt. If you want to understand Kuiper belt is just the municipality of our solar system. Okay, this is the municipality of our solar system. In other words, you may say that this is a great ring of debris which is found beyond Neptune. This is a great ring of debris found beyond Neptune. Okay. These are asteroid-like belt Kuiper belt is asteroid-like belt which is remnant of our solar system. So let me clarify, when solar system was getting formed, so that time some remnants were left. So those remnants were accumulated beyond Neptune, and that is really a kind of debris for us, is known as Kuiper belt. So Kuiper belt is found beyond Neptune. So can you see Pluto is in the Kuiper belt only. Because of that, it is unable to clear off its surroundings. That is why it is not a planet. Yesterday's last topic, Pluto was failing the criteria that it is unable to clear off its surroundings. Why? Because it is falling in Kuiper belt. So that is why Pluto is not a planet. Is it fine? This asteroid belt, there are very less rocky objects. For example, if we ever get to accumulate all the asteroid objects, the mass will not be more than that of Moon. But in Kuiper belt, the mass is way beyond our imagination. Okay, there is too many rocky objects there. So that is why I have written asteroid-like belt, which is remnant of our solar system. Is it fine? So this is your Kuiper belt. And in Kuiper belt you can find your comet, etc. As I told you, this is house of comet, and second house was Oort cloud. So if comet has short life cycle, Kuiper belt will be the house, and if comet has longer life cycle or longer cycle, Oort cloud will be the house. So this is your Kuiper belt. So I hope you must have written this, nothing more to be dictated. Now I will discuss something called heliosphere and hydrogen wall. Suppose this is sun. So solar winds emanating from sun forms a shape of a bubble. Okay. So the solar winds which are coming out of sun, solar wind, these are solar winds. So they form a shape of a bubble. This bubble is known as heliosphere. This bubble is known as heliosphere. Let me clarify on this bit. Have you ever filled air in a balloon? You must have. So you know that after filling some air, you should not blow it further, else the balloon will burst and will slap you on your face, right? The same happens with sun. There is also a limit of sun. You can understand that sun is blowing a balloon, okay, and this balloon reaches up to a level. If you see, your major planets end over here. So this is the last planet you are having, Neptune. So the extent of this heliosphere goes well beyond the 8 major planets, and up to this range the sun has its impact, because this heliosphere is unable to cross an area which is filled with hydrogen. So this area is having hydrogen. So that is why this is known as hydrogen wall. I repeat, solar winds coming out of sun forms a shape of bubble which goes beyond the 8 major planets. This bubble is unable to penetrate an area filled with hydrogen. That area is known as hydrogen wall, and this also marks the end of our solar system, not the galaxy, solar system. Because if sun's reach is not there, how can you imagine solar system beyond that, right? So first you write this, then I will again say something, right? Solar winds emanating from sun forms the shape of a bubble. Forms the shape of a bubble. Forms the shape of a bubble that extends beyond the major planets. That extends beyond the major planets. This bubble is heliosphere. This bubble is heliosphere which is unable to penetrate an area of hydrogen called the hydrogen wall. Called the hydrogen wall. Called the hydrogen wall. This also marks, means hydrogen wall, this also marks the end of our solar system. This also marks the end of our solar system. Now just see this. Solar winds are coming and it is going beyond. So whatever is falling in this vicinity will be part of your solar system, right? Whatever is falling. For example, Oort cloud is falling. For example, Kuiper belt is falling. So that will be part of your solar system. Okay. So this is your solar system. After this, sun's impact is gone. That is hydrogen wall. So solar system ends over here. तो छठ पूजा यहीं तक होती है. Is it fine? Beyond this, there is no छठ पूजा. So this is one solar system. Next thing, suppose there is some other star. Okay, so this is another star. So there will be hydrogen wall for this star. I am just making like this. There will be some other star. Hydrogen wall for this star. There will be some other star. Hydrogen wall for this star. Means this, that is also hydrogen wall here where it is ending, right? So the hydrogen wall for this star. This star will also have its planet. This star will also have its planet. This star will also have its planet. Right? These planets are known as exoplanets outside the solar system. Understanding this or not? Because that is outside the solar system. So there is a concept called Interstellar, the movie I had asked you to watch, or JL50, the web series I had asked you to watch. Whatever you wanted to watch, just watch it, if possible. So now just see Interstellar. What is Interstellar? Okay. So stellar means star. That is why stellar energy was written in fusion reaction, right? Stellar means star. Inter means between the star. So just consider what is between my heart and my stomach. I guess if I had to roughly say, blood I can say, roughly, though this is not the case, but understand that between the organs, blood is the carrier of energy and whatever you want to say. Is it fine? So whatever is this space between the star, which is not claimed by any of the star, is your interstellar. Okay? Whatever the space is between the stars, that is unclaimed space, is known as interstellar. Consider this as your house in the colony. This is your house. For example, I am saying, this is Mishra ji's house, this is Subramanyam ji's house, and this is, suppose, what we say, any you say, Pandey ji's house. There is no issue. Okay. Now suppose this is your house. So this is what is the boundary wall of your house. So this is your space, this is your claimed space. This is Mishra ji's house, very small, but this is his house, his boundary wall. Same is with Mr. Subramanyam and Mr. Pandey ji, right? So this is what is the boundary walls. So whatever will be the road or the unclaimed area, that is for all. So that unclaimed area, the parking area, or even the garden, or even the roads of the colony, that belong to everyone, because that is neither claimed by Mr. Mishra, nor by you, nor by Mr. Pandey, nor by Mr. Subramanyam. That is common area. So that also happens with the star. This is the limit of this star, this is the limit of this is the limit of this is the limit of this star. So whatever is the unclaimed space between the stars, that unclaimed space is known as interstellar. Okay. So what is between the star? This is interstellar. Earlier it was thought that interstellar is vacuum. Okay. But now it is thought that it is not vacuum, it is hard vacuum. It will appear as vacuum, but it will not be vacuum. By hard vacuum I mean there will be dust, there will be gas, there will be plasma. Plasma means charged gas. So dust will be there, gas will be there, plasma will be there, something else will be there, I don't know. Yes. Cosmic radiations. So cosmic background radiations will also be there in interstellar. That is why it is termed as hard vacuum. So this is your interstellar. Copy it. Okay. Now we have Oort cloud. Okay. So where Kuiper belt ends, okay. So Kuiper belt also goes beyond Neptune. So the reach of sun is also weak there, right? Because the distance is increasing. So because of that, some icy substance starts getting formed. Those icy substances or those icy belt is known as Oort cloud. Okay, so that will be very icy in nature. Since the reach of sun is very weak, so the size may be even bigger than the mountains. Okay, so these are Rohit is asking, heliosphere, is this bubble unidirectional or all directional? No, it can be all directional. Okay, I have just made the one side of this. Okay, every direction. Okay, Rohit. Write Oort cloud first. Icy objects. These are icy objects at the distant edges of. These are icy objects at the distant edges of Kuiper belt. Distant edges of Kuiper belt. This also marks the outermost layer of our solar system. This also marks the outermost layer of our solar system. The size of Oort cloud may be bigger than mountains. May be bigger than mountains. May be bigger than mountains. So where the Kuiper belt ends, Oort cloud starts. And as the Oort cloud will go far away from sun, the size will definitely increase, the icy object will be bigger. And this is the house of, again, comets. So try this question. This question was asked by UPSC in 2015. The term was very much in news. I just want you to know the concept that if they ask Goldilocks zone once again, just as a statement, so you should know that what is Goldilocks zone. So if you know this, it is okay. If you do not know, yes, Rohit knows it, very good. Utkarsh is also right. And Chhava is also right. Option C is the right answer. So those who are not knowing, please write it. Goldilocks zone means search for Earth-like planets in outer space. Search for Earth-like planets in outer space. Because see, someday sun will be gone. When sun will enter into red giant phase, definitely the storms etc. on Earth will be increasing. The energy you are getting from sun will not be that much. Earth will become cooler. The temperature variation may lead to extinction. So many other things can happen, right? So that is why the search is inevitable. We'll have to leave this planet someday. But you and I won't be there for that gloomy period, but okay. So I hope you have written. Option C is the answer. So just copy it. Now we'll see two more concepts for today. One is your force carrier, other is your antimatter. So force carrier. Actually, if you again ask me that what is force carrier, the correct explanation lies in quantum physics. Okay. Physics has 4 different dimensions: classical mechanics, quantum mechanics, relative mechanics, and relativistic theory mechanics. All are having separate domain. For example, classical mechanics is applicable on Earth, relative mechanics in space, quantum mechanics at the size of atom, and relativistic theory mechanics is the sum total of all, which is yet to be developed. But this will be really hardcore understanding, so we will not enter there. We'll try to understand force carriers in more layman term or more easy term. What is a carrier? Carrier is something which carries you, right? So force carrier will be something that will be carrying the force, as simple as this. For example, force carrier are the smaller units that will guide to the bigger unit. Force carrier are your childhood photograph, and force is the photograph of present. Are you getting this? So just understand like this, that force carrier carries the force. Okay. So force is a bigger entity that travels over this. Means multiple force carriers will lead to force. Multiple force carrier. Okay. We'll understand. First, draw this table, then we will discuss. copy this first. Okay. Now I told you that force carrier is something that will carry the force, right? For example, let's start with the known thing. The first lecture, photon, in which I had told you light is nothing but packet of photons. Yes, you remember that millions of photons are coming together to give you a ray, like millions of water droplets were coming together to give you streamlined flow of water, or to give you continuous flow of water. The same fashion, millions of photons come together to give you light. So that is why photon should be carrier of electromagnetic wave or light. Okay. In nature, we are having only these four fundamental forces. Other forces are just the corollary. We have only four fundamental forces. And if you see the magnitude, this is the strongest force, this is the second most, and gravitation is the weakest among all. So that is the magnitude of strength. You can make a table also, magnitude of strength, and rank it that way, whatever you want. Okay. In the same fashion, if this pen if this pen is falling like this, so gravitation is pulling it. So in force carrier term, you can say that though gravitation is acting, but millions of gravitons are carrying this pen, and that you are called collectively as gravitation. Are you getting this? The force is just a collective term. There are simpler particles that are giving it that blow. Is it fine? Like millions of photons making electromagnetic force or light. So this strong force is having a force carrier of gluon. If you remember this, strong force just binds the nucleus. Binds nucleus. This is the purpose. Now remember, so nucleus binding will be done by proton as well as neutron. So you remember proton, 2 up quark and 1 down quark. This was your proton. Okay. So these quarks are bound together by gluon. So this is a gluon. This bond is again a gluon, that bond we were making. So this is like a glue. So that is why it is known as gluon. Just they have named it like this, okay? Do not understand like this. Today research is more important, but I am telling you, just 100 years ago, the research was going on the whims and fancies of the scientist, okay? Einstein has given many theories based upon his dreams, but he has proved it. I don't know how. Now just see another thing. This is what is your neutron. Okay. So again, how these quarks are bound together? Again by gluon. So this is again a gluon. So gluon is this binding force, the force carrier among the quarks. So this is the force carrier among the quarks, that it is binding something together. Next is your weak force. This is breaking nucleus. This breaks nucleus. For example, beta decay. So what is happening over here? Nucleus is breaking down. Radioactivity. Here also nucleus will be breaking down. Radioactivity is broader term. It will also comprehend other sort of decay also. So are you finding that electron or neutrino will be coming out? So W is the force carrier for electron and Z is the force carrier for neutrino. So if nuclear is breaking down, who is breaking down the nucleus? Who is taking something out of the nucleus? It is W and Z boson. Boson is a term used for force carrier, I have told you. Okay. So if suppose this nucleus is there and suppose electron is coming out of nucleus. So which is taking out electron out of the nucleus? So it is W boson. If this is nucleus, if neutrino is coming out of the nucleus, neutrino is denoted like this. So he is taking out this neutrino. This is Z boson. So if there is decay of the nucleus, if nucleus is breaking down, then weak force will be responsible for this. And the third one is electromagnetic. So light, everybody knows. Photon carries light. In first class we have seen it in detail. And the fourth one is graviton. So graviton will carry gravitation. Okay, there is no issue. In our solar system everything is bound by gravitation force, everything. But let me tell you, we have evidences of gluon, we have evidences of W and Z, we have evidences of photon. But we do not have any evidence of graviton, so this is imaginary. Graviton is not yet found. Graviton is not yet found, hence the physics is not unified. I would not ask you to read newspaper for this, because the technology we are having at present is not sufficient of finding graviton in coming thousands of years also, or even hundreds of years. So your life will be over, but this won't be found. There is a string theory which defines graviton. Okay, I am not going to discuss string theory. Not required. Why to make things complex? So this is the table you need to remember. Questions have been asked by UPSC based upon this table. Okay, so if you remember this table, if other questions are asked, you will be able to answer it. Okay, so just in brief I am just repeating it and then I will show you
that strong is binding the nucleus, so it is the force acting among the quarks. And if something is taking something out of the nucleus, means breaking of nucleus, that is done by the weak force. Electromagnetic, that is photon is carrying light and graviton is responsible for gravitation. But the last one is imaginary, because of that physics is not a unified theory. See the PPT. So this is the photon, right? The photon is nothing but carrier of light. So wherever you find light, so you can easily say that force carrier will be photon. This is your gluon acting among quarks. With this we have a question. After this question I will again show you something, but try this question first. Okay, Rohit and Utkarsh have given the right answer. Very good. Okay, Palash has also given the right answer. Sandeep Kumar Yadav, yes, you are also right. Option A is the right answer, because question is asking which of the following is not correct. So gravity is the weakest among the four. Chhava, you are also right. Okay, gravity is the weakest among the four, and the first statement is saying it is strongest. So lepton was giving this, just see this quark was there. So that linkage is gluon, that I have made on the board. Okay, this linkage is gluon. Now antimatter, the last topic of the day. But before that, Rohit has a question. Can we say that gluon has a nuclear force? No, Rohit, you cannot say this. You can understand like this, that because nuclear force will be something very heavy. Nuclear force or nuclear energy is humongous. It is just a binding force for the nucleus, gluon. Okay, it is just a binding force. Yes, the manifestation can be very strong. So let's not simplify this at that level. So now come to antimatter. So before dealing with antimatter, I will write the reaction, beta decay. I hope most of you must have forgot. In beta, in radioactivity we have done this. So we have beta plus decay, and then we have beta minus decay. So beta T plus decay, here protons were more than the neutrons, and in beta minus decay here neutrons were more than the protons, right? So here proton was giving you positron plus neutron plus neutrino. This is positron, and here we were getting neutron was giving us electron plus proton plus antineutrino. So antineutrino was antimatter of neutrino. And positron was antimatter of electron. Antimatter of electron. So I had left this saying that in last class I will tell you about antimatter. So today is the day I will tell you, because we are having 15 minutes extra time. I am telling you we are 15 minutes ahead in your batch. So tomorrow maybe we will finish around 12:30. Okay, so your syllabus will be over tomorrow by 12:30. We will have that liberty tomorrow. So what is antimatter? These are just opposite of matter, but with opposite charge or opposite spin. Suppose electron is moving in clockwise direction. Suppose I am saying, so is clockwise direction this way, okay? This will, then positron will move in anti-clockwise direction. Are you getting this? So it will have opposite spin as well as opposite charge, or either of the two. For example, opposite spin is also important, because what about antineutrino? Neutrino is chargeless. So antineutrino will have just the opposite spin, na? So that is the idea. So either it will have opposite spin or opposite this. Means if I am moving forward, antiparticle will move backward. Christopher Nolan, okay, he is the physicist. I hope the movie is, have you watched the movie Tenet? He has gone for the extreme justification of this antimatter. So Tenet is just the corollary of antimatter. And Interstellar, he has tried to revamp the theory of relativity. Okay, so he is a great guy, good knowledge of physics. That is why he is making such movies. But movies are really complex to be understood by a general man. For example, in Interstellar, he has taken many concepts together. For example, string theories, everything he has taken. So that is why I asked you to watch GL50 instead. And here in Tenet, he has gone for the extreme justification, because these all are theories. We have only few things proven, not everything, but Nolan has taken everything. For example, when he had made Interstellar, he had shown black hole in the movie, okay, upon his understanding and whatever. And when we got the picture of black hole, okay, not the accurate picture is not yet available, it was more or less similar to Nolan's understanding. So that is why he was awarded some prize in physics also. So I am his fan, what he does, but no issues. Come here. So I am just telling you what is antimatter. So antimatter is just opposite of matter, having either opposite charge or opposite spin. If I am moving forward, antimatter will move backward. That is what is antimatter. Okay, and charge will be just opposite. After Big Bang, both matter and antimatter both were formed. So everybody knows E equal to mc square, the equation given by Einstein. That energy is generated by this reaction, and this was really misused. Okay, no issue. So mass is giving you energy. After Big Bang, energy gave you mass. So whatever your accumulation of energy. So this energy formed both matter as well as antimatter. Okay, these formed both matter as well as antimatter. If 10 to the power 9 matter was formed, antimatter was formed 10 to the power 9 minus 1. Just a slight difference. If that amount of matter was formed, just one less amount of antimatter was formed. Means almost equal, but matter was having some advantage after Big Bang. But there was issue. Matter and antimatter both are enemies of each other. So you may understand matter as Dawood Ibrahim gang and this as Chhota Shakil gang. So what happens if two enemies meet? They kill each other. They wipe out to rule the industry. For example, the underworld industry. So Dawood Ibrahim gang when see Chhota Shakil gang, they start firing upon them and vice versa. So what will happen? The bigger gang will survive and a smaller gang will be wiped out. Only a few members will be left and they will also seek asylum and they will go underground. Is it fine? Two gangs are fighting, the bigger gang will survive, the smaller gang will be wiped out and only few members will be left. Is it understood or not? The same happened. Matter and antimatter, both are enemies of each other. There is property. If matter and antimatter will collide, they will annihilate, flashing a lot of energy. So if matter and antimatter are colliding, they will annihilate a lot of energy. Suppose I am matter and I accidentally meet the antimatter of mine. Never ever do one thing that out of emotion you went and you just hugged the person or you just shake hand with the person. Highly chances both will annihilate. Okay, if there is a touch between you two people, you will annihilate and a lot of energy will be released. So matter and matter both are antagonistic. So we are trying to find antimatter. So because of this fighting between matter and antimatter, today antimatter are rare because very few are left. Mostly matter is left. Okay, we have created antimatter in labs, at Fermi lab, at CERN, we have created it. Now, how much energy is released? This should be the concern of yours. For example, have you seen safety pin? Safety pin? Yes. Ask your mother if you have not seen. Girls must be knowing. So safety pin, suppose matter is of that size, antimatter is of that size. Okay. So if safety pin size matter collides with safety pin like antimatter, the energy released will be sufficient to take Mangalyaan to Mars. Okay, that Puri Banao Yojana, okay, that was taken into consideration to send Mangalyaan to Mars. But just think, just a size of safety pin, okay, if these two are colliding, that is taking that spacecraft to Mars. Don't you think this is very unique? This much energy just within a safety pin. Just think if you are having that thing in your bigger antimatter and bigger matter in your bucket, how far the space missions can go. So that can be really game changing. But making antimatter is not that easy, because changing the spin of subatomic particles or changing the charge of subatomic particles is very, very difficult. This happens only in nature. This happened only in nature very easily, but for us it will be very difficult. So please write antimatter. Antimatter are just opposite of matter. Antimatter is just opposite of matter. They resemble matter in every sense. They resemble matter in every sense, but have opposite charge, and opposite subatomic characteristics, opposite charge and opposite subatomic characteristics, but they have opposite charge and opposite subatomic characteristics. Both matter and antimatter were formed after Big Bang. Both matter and antimatter were formed after Big Bang. But today, antimatter is rare in universe. But today, antimatter is rare in universe. When matter and antimatter interact, they annihilate or destroy themselves, whatever you want to write. They annihilate, releasing a lot of energy. Example, positron, antihydrogen. Example, positron, antihydrogen, etc. Okay, so just see the PPT. This is your hydrogen. Electron is revolving around proton, right? Just see antihydrogen. So in antihydrogen, instead of electron, we will have what? Positron. So positron will be revolving, and instead of proton, what will be there? Antiproton. Antiproton means proton pe minus charge on proton, and positron means electron pe plus charge. So this opposite setup will be called antihydrogen. Understanding this? So proton was this, up quark and down quark were making it. So antiproton will be made by anti-up quark and anti-down quark. Just opposite spin will be there. So it will be made by anti-up quark and anti-down quark. So positron is just opposite of this. Try this question. UPSC has asked once. So tomorrow we will be covering dark matter, Bose-Einstein condensate, the fifth state of matter. Then we will touch dark energy. We will be also doing few concepts of theory of relativity, not in much detail, and we will be doing Higgs boson. Okay. So that will be the agenda of tomorrow, and I guess around 12:30 we will be finishing the same. So if possible, do watch GL50. Just I guess 2 hours time will be required. So what should be the answer? A team of scientists at Brookhaven National Library, including those from India, created antimatter, antihelium. So what are the benefits we are going to have? Rohit has come with the answer. Okay. It will make mineral prospecting and oil exploration easier and cheaper. It will help probe the possibility of existence of stars and galaxies. Rohit, you are right. Option B is the right answer. Okay. Just see, I have not taught you that it will help you in mineral exploration. In other galaxies or other part of universe, there may be chances of antimatter. In our galaxy, it is not found. Okay. So there are chances that antimatter may be formed in other galaxies. So there is a possibility. And third is, since it was formed during the time of Big Bang, so don't you believe that it will help you in understanding the evolution of universe? Because it was formed at that time. Chhava, you have missed something. Option 1 is not right. Okay. Understanding this, since it was formed during the time of Big Bang, so it can have the information of evolution of universe. So third statement is bound to be correct. And second, because other stars and galaxies may be of antimatter. I told you, there are antimatter of everything. Okay, there is a possibility that antimatter of mine is also available. There is anti-galaxy of this thing. Okay. Okay, so the next concept will be dark matter, that we will see tomorrow. Okay, so let's meet tomorrow. Tomorrow is very important class. Okay, thank you.